Okay, so now we know about our steps that we go through to pen test a firewall. The next thing would be to, if they have an IDS system, you would want to pen test it as well. And we're going to start off very similar, the same way, by disabling a trusted host. By doing so, we are able to then go through and pretend like we're one of those hosts or that trusted host by spoofing its IP address. And we can do things like do an insertion attack. Now, using this type of attack, the pen tester can try to defeat signature analysis of the IDS system. And again, I got to reiterate, if you're not familiar with some of these terms, you need to go back, and in this case here, watch our course on ethical hacking, firewalls, and intrusion detection systems. Our next step would then be to try an evasion attack. This type of an attack is a technique that allows the attacker to get the IDS to reject a packet that the end system accepts. We would then also try to do a standard denial of service attack. Again, this takes place when the attacker sends so much data to the IDS system that it can't process every packet. Very similar to a flood. And because it's so busy, it allows malicious traffic to actually pass through without being logged. You would then try to do an obfuscation test. An IDS system has to be able to detect all malicious signatures regardless of their format. So to confuse the IDS system, you could go through and encode traffic, encrypt it, or even fragment it so that it's so obscure that the IDS system just ignores it. Our next step would be then to create a ton of false positives so that it's difficult, if not impossible, to identify where the real attack is on the IDS system. We overload the log files, kind of similar to the boy who cried wolf, right? After we do that, our next step would be then to try to do a session splicing. In session splicing, what you do is you deliver data in multiple small size packets, and it becomes very difficult again for the IDS systems to detect attack signatures of these types of attacks. Next, we want to attempt to do a Unicode evasion. Unicode is a character representation that gives each character a unique identifier for each language. So, for example, a backslash could be represented by 5C. The computer sees the backslash and the 5C as being the same thing, but the IDS system may be only looking for a backslash. Next on our hit list would be a fragmentation test. Now, in a fragmentation test, now the concept here is that fragmentation reassembly timeouts of a victim is typically more than the IDS fragmentation timeout. So, pretend, for example, that you've got 15 seconds is your IDS fragmentation reassembly timeout, and the system that you're hitting has a 30-second timeout. Well, we can simply send the second fragment with a delay of 15 seconds, but still be within the 30 seconds after sending the first fragment. And what happens is that the target reassembles the fragments. At the IDS, the fragmentation reassembly timeout parameter kicks in and the timeout takes place. As the IDS has already lost the first fragment due to the timeout, the second fragment received by the IDS will be dropped. So in essence, the victim will reassemble the fragment and will be attacked, where the IDS won't even notice anything at all. Another test that you'd want to try to implement is an overlapping fragments. Now, in this case, the attacker sends packets in such a way that the one packet fragment overlaps data from the previous fragment. And the packets are actually designed in such a way that the victim's computer will reassemble the packet. And in that packet, we'd have an attack string that gets executed. Since the attack string is fragmented, the IDS is unable to actually detect it. But wait, there's still even more that we can test. We'd want to try a TTL test or a TTL attack. TTL, again, being short for time to live. In this type of attack, we take advantage of TTLs that have been set both at the IDS system and at the victim's system or the target system. And we can use tools like traceroute to determine what the TTLs are. We then want to test for any vulnerabilities to an invalid reset packet. In this case here, we send invalid reset packets with an invalid checksum, which causes the IDS system to stop processing the stream as the IDS thinks that the communication session has actually ended. However, the end host sees this packet and drops the packet if it's invalid after verifying the checksum. In fact, some IDS systems will actually stop reassembling the communication as they look at this packet as an actual termination of all communication. We would then want to try to do an urgency flag test. Now, in this particular case, some IDSs actually don't consider the TCP protocol of urgency being a feature. So what happens, we just place garbage data before the urgency pointer, and the IDS reads the data without considering the end host's urgency flag. Next up on our test would be to then look for any polymorphic shellcode attacks or vulnerabilities. In a polymorphic shellcode attack, just like we know about polymorphic viruses, they're always changing, right? So what happens, we send a malicious data that continually changes its signature. Since the new signature of the data doesn't match the old signature entered into the IDS signature database, the IDS is unable to point out any mischievous or malicious data, and therefore it passes right through. Next in our wonderful list of tests on these IDS environments is to look at an ASCII shellcode attack. Now when it comes to ASCII shellcode, this particular test isn't all that powerful, because what we're actually doing here is we're actually bypassing, or we're attempting to bypass, commonly enforced character restrictions within the string input code. And so because it's come across as ASCII, the IDS pattern matching signatures don't really pick it up. The other issue that we have here is that assembly instructions that we might try to execute, not all of them can be converted directly over to ASCII values. So it kind of limits what the shell code can do under certain situations, but it's definitely something you need to still examine. We then have the application layer attack or test. Many IDS systems fail to check the compressed file format for signatures, such as a MP3 or a JPEG or even an MP4. All these applications are already compressed. And this is designed to obviously increase data transfer speeds by not looking at those files. Most of the time we have IDS systems that are looking for a particular condition that leads to an attack, where instead we can actually place within the compressed data the entire attack, and the IDS system has no way of checking that compressed file format for any signatures. We'd also want to try to implement or test for encryption or flooding. When it comes to encryption, it's actually one of the more effective evasion attacks because we've created an encrypted session with the victim and the IDS system can't look at it. Same thing with flooding. Well, I shouldn't say same thing, but very similar. With flooding, a true attack traffic may go undetected if we send a ton of unnecessary traffic to produce a lot of noise. And it's kind of the same thing with flooding. Well, not really. Just a different approach here, but we're going to go through and create or send a ton of traffic, and what it ends up doing is creating so much noise that the IDS system can't monitor it or can't look at it. It's almost overloading it. We'd also want to go through and try both post-connection SYN and pre-connection SYNs. Now in the case of pre-connection SYN attacks, these actually are calling to bind in order. This attack, the initial SYN is sent before the real connection with a invalid TCP checksum. What this does is it causes the IDS system to start synchronizing with a sequence number that's kind of bogus before the real connection actually takes place. With the post-connection SYN, the IDS should actually try to desynchronize from the actual sequence number that the kernel has been honoring up until this point. Again, if you're not familiar with these techniques, go back and watch our video series on firewalls and intrusion detection systems. So after we do that, guess what's next? Go ahead, you can do it. Yeah, that's right. You're going to document again what it took place on the IDS system. Now, as I mentioned before, some companies may not have IDS systems. They may only have firewalls, or they may have a combination firewall IDS system. Regardless, our goal here is to see what can be bypassed, either from the outside or from the inside going out.